Hi, I'm Shaylynn Hayes-Raymond from the International Misophonia Foundation, and I'm very fortunate today to be here with Dr. Joseph LeDoux, who is a neuroscientist and musician, and of course, an author. And today we are going to talk about that book, if it'll let me show it. I guess, like existence, it's kind of trying to come in and out of consciousness. And Dr. LeDoux, would you like to tell us about yourself?
Well, I'm a neuroscientist. I have worked at NYU, New York University, since 1989, most of my scientific career. And I'm in the Center for Neuroscience there, but also have appointments in psychology and child and adolescent psychiatry and adult psychiatry at the medical school. They're just kind of courtesy appointments rather than actual. I don't teach psychiatry or child psychiatry or anything like that. Before that, I was a postdoc at Cornell Medical School for about 10 years. Well, I started as a postdoc and got some medical school rankings, the research assistant professor, research associate professor, and all that kind of stuff. But I never felt comfortable in a medical school because you're always a kind of second class citizen unless you're a doctor. So I was very happy to get a job at NYU. Now, before that, though, I had two degrees in business. I had an undergraduate degree in business administration and a master's in marketing before I actually discovered that there's a thing called the brain that does things.
I actually find that really funny because before I got into this master's program in counseling, I have a degree in creative digital media and was a marketer and web designer for 10 years. So it's almost like you never know where it's going to lead you. But
Yeah.
I think marketing too, you're spending a lot of time thinking about how people think in that sphere.
hmm Yeah, so it's interesting that I did my my master's thesis in marketing on post-purchase cognitive dissonance. So the idea was that I connected with a car dealership in this was in Baton Rouge, Louisiana, where I'm from Louisiana, so I was studying there at LSU, and so the idea was that they gave me a list of people who bought cars, and half the list I called and said, I was a service representative or some kind of customer representative for the company, and we wanted to make sure everything was working fine with the car, and if they had any issues, and did they love it, or was there any problem, blah blah blah, and they answered a bunch of questions, and then the other half didn't get contacted at all. So then we did the statistics on it. There was some small difference between those who got called and who didn't. So it wasn't like a brilliant, very like rigorous kind of scientific discovery. But what's interesting is that when I ended up, during that time, I was studying, trying to take a bunch of psychology classes so I could learn how to, you know, I was into consumer protection. So I was interested in, as you said, how the mind works and uh, how we could help people make better decisions. And I took a course called Learning and Motivation. I thought that would be about human learning and motivation, but it turns out it was about rat brains and how they learn and how they're motivated and stuff. And I just, being a little kid from
Gateway
a small
drug.
town in Louisiana, I didn't know you could study the brain. So I fell in love with what that guy was doing and applied to graduate schools. And I was accepted at Stony Brook, but nowhere else. And the reason I was accepted at Stony Brook is because the professor at LSU knew someone at Stony Brook. So they decided to take a chance on me. And that's where I met my mentor, Mike Zaniga, who was working on split brain patients. And that's what I did my PhD on. And sort of interesting is that my PhD unintentionally included discoveries about cognitive dissonance as well. So my master's and PhD in different fields all focused on cognitive dissonance.
It seems funny how things just seem to work out like that.
Yeah, life is just a bunch of random happenstances.
I also find that really interesting because I've been doing a lot of research myself on like shopping addiction and
Uh-huh.
also gambling and gamified shopping and like I don't want to say hoarding, but like collecting and how
Yeah.
like all these things are coming together. And because
Yeah.
we live in a capitalist society, no one cares. So like whatever, keep buying.
Well, you can see I have guitars on my wall that
Mm,
you said hoarding. There's something called GAS, GAS,
yeah.
guitar acquisition syndrome. I don't have as many as a lot of people. I have about 7 guitars. Some people have like 20, 30, 40 guitars.
It's shameful for me because all my guitars are for Guitar Hero. They're plastic. I did buy one electric guitar that I have no idea how to use,
Uh,
but I'll try.
what did you buy?
I don't know. I'll be honest. I don't know. It's a guitar though.
Okay. You have an amp?
No, but
You need an amp or electric?
I was going to learn through it's called Rocksmith. It turns your Xbox into an amp
Okay.
and teaches you how to play at the same time.
Okay.
So I'm gonna try that to
All
start.
right. Good
So
luck.
basically I'm upping my Guitar Hero game. So I guess I didn't even write this question down. And I was wondering, what really, I know you mentioned how you got to science, but what got you to neuroscience specifically? Like, that's a very
Just
deep
I
path.
took a class that the guy was studying the brain and said, okay, that's what I want to do. Coming from a small town in
Hmm.
Cajun country in Louisiana, I didn't know anything about um studying the brain, but actually as a kid in my father's meat market, my job was to remove the bullets from the cow brain.
Hmm.
So I knew I had held a brain. I'd taken the brains apart. I'd put my fingers in them to pull bullets out. And so I actually learned something. And so I was always kind of interested in the brain, but I never, you know,
Hmm.
got around to thinking that you could actually study that sort of thing. So it was like an eye opener, and I really published a couple of papers with that professor at LSU who was studying the brain, and it just one step led to another, and I happened to meet Mike Gazzaniga at Stony Brook. I could have worked for anybody, get assigned to someone,
Hmm.
but I ended up with him, and he was studying split brain patients. These are people in whom the connections between the left and the right hemisphere have been sectioned in an effort to relieve intractable epilepsy. So
Hmm.
these people, these were often children or teenagers that had no social life, no real life, because they had such bad epilepsy, and the medications weren't very effective at that time for severe epilepsy. And this, I don't know how someone discovered this, but somebody figured out that if you section the connections between the two sides, the seizures don't bounce back and forth much, and so it's a little easier on them. But
Hmm.
that's not what we were studying. We were studying the psychological consequences of all that. And it was Mike had done his PhD on slip brain patients at Caltech in the 60s and made all the primary discoveries, like language in the left hemisphere, right hemisphere doesn't have language. So if you show the left hemisphere a picture of an apple and say, "What did you see?" it can say, "I saw an apple." But if you show the right hemisphere a picture of an apple and say, what can you see?" The left hemisphere is the only one that will respond because only the left can talk. But the right can point to the apple as
Hmm.
and pick it out of a group of pictures. So the right hemisphere processes the information but can't talk about it.
Hmm.
So the question that kind of came up in all this work was, are there two people living in those two hemispheres, or is it just one person? And it was very hard to test that because without the ability to probe the right hemisphere linguistically, you can't ask it sophisticated questions. But we had one patient who we discovered happened to have a little bit of language in the right hemisphere as well as full language in the right and the left. And this patient could read pictures that we would show to the left hemisphere. So if you flash some information on a screen on the left side of the screen, it goes to the right hemisphere. Like, of
Wow.
course, the right hemisphere could point to it, as I said. But we also said what we also found was if we put put words into the right hemisphere, it could respond in the appropriate way. Like if you put the word stand in the right
Hmm.
hemisphere, the person would stand up.
Wow.
It
That's
couldn't tell.
fascinating.
And so it was so interesting that, it could actually do that. Or if you put in, who are you? He was able to spell his name with Scrabble letters using his left hand. Paul, Paul. And his
Wow.
girlfriend Liz could spell all that. And the right hemisphere occupation or goal in life was to be a race car driver, and sorry, a draftsman. No, a race car driver. And the left hemisphere wanted to be a draftsman or an architect. So all of this was suggesting, okay, he's got a sense of self in the right hemisphere. He knows his name. He knows his social interactions. Has a goal for the future. So
Hmm.
there was someone home over there in this kid, probably because there was so much language over there that allowed the kind of human personality to develop. So, but the most amazing experiment was one where we put two stimuli simultaneously. One went to the left side of the screen and to the right hemisphere. The other on the right side went to the left hemisphere. So on the right side was a picture of a chicken claw. This is a country boy, so we showed him things like that. So there was a picture of a chicken claw, and the right hand points to a chicken. On the left side was a snow scene, and the left hand points to a shovel. So then you ask the boy, in other words, you ask his left hemisphere, why'd you do that? Without missing a beat, he says, well, I saw a chicken claw, so I pointed to the chicken, and you need a shovel to clean out the chicken shed. So the left hemisphere had no knowledge at all about the snow scene. It only knew about what it was seeing. It knew it saw a chicken claw, so it pointed to the chicken. And what goes with a chicken and one of these was other stimuli. He was pointing to a shovel, so what goes with a chicken and a shovel? Clean out the chicken shed. So it was a kind of narration or interpretation of the situation in which he found himself. So after all these studies took place in New England because the patients were operated on at Dartmouth Medical School.
Hmm.
And so we would stay in a hotel, for a couple of days. And each night we would go to the hotel cafe to have something to eat and have a drink and talk about what we saw. It was this kind of relaxation, downtime. And we were talking about, what is going on here? I mean, one possibility was to say, okay, this is confabulation, which many neurological patients do because they try to compensate for the deficits produced by their brain injury. And there's probably something to that. But the insight we had that evening in Bennington, Vermont, at the bar, was that this is not just something that happens when you have brain damage. We are constantly narrating our lives. We're constantly interpreting our behavior on the basis of what we see ourselves or hear ourselves doing. And so our idea was that, there are all these systems in the brain that can produce behavior unconsciously, non-consciously. And we all believe we have free will. So if the conscious brain sees behavior being produced non-consciously, it's disturbing. It produces cognitive dissonance to think that you don't have control over your, key behavioral responses. So
Hmm.
the idea was that what we do, that the human brain evolved some ability to tell stories, to generate stories, not only about the outside world, but about what you are doing to make it all make sense. Imagine you're with your partner and everyone has experienced this at some point in their relationship. One of the members of the couple let's say it's you say something angry and you regret it.
Oh, I have
You,
misophonia, so I don't have to imagine.
okay. Well, okay, let me put it in my perspective. I say something angrily to my wife, and so immediately I know that's happening. So the
Hmm.
question is, how do I narrate that? Do I say I'm right and I'm not going to go pull back on it? Or do I realize that I'm wrong and I say, oh, I'm sorry, I did the wrong thing? If I just let it go, obviously the next day I better do the right thing because the relationship depends on it. So
Hmm.
we do these things and then we have to narrate them. So narrations are just a key part of human existence, and it's often been said that humans are the storytelling animals, and I think that's really true. So that's a very long-winded way of saying how I got interested in consciousness. And um, the other thing that happened at the bar, I don't think it was the same night, but on a different night, we'd always go have a Jack Daniels or two before dinner. And we was just sort of like joking around, talking, and we'd done some little experiments on split brain patients and emotion, and I was kind of into that. And so Mike said, there's not a lot of research on emotion in neuroscience these days. You should think about that. And I did, and immediately said, okay, that's what I'm going to do. I mean, it was
Well,
like,
thank God you did, considering all the work that came from that.
uh, but I said, what I realized was there were no techniques for studying the human brain at that time. That
Hmm.
there was no brain imaging or anything like that. So
Yeah.
you had to wait for a patient to come along that had the right kind of brain damage. It could take years to get 2 or 3 patients. Um, but what I was interested in was the emotional behaviors that we do non-consciously
Hmm.
that might cause us to have these dissonance reducing narratives generated. So I decided, well, maybe rats and humans have similar neural circuits for controlling behavior. And there was, pretty good evidence for that. So even though I couldn't study emotional consciousness in rats, I could study emotional behavior in them, and it would be
Hmm.
relevant to the human brain. And then when I would write, so all my research papers were on emotional behavior. But when I
Hmm.
would write a book chapter or an actual book, I would always talk about consciousness in terms of those narrations and the cognitive interpretation of the situation. So those are the two things I've done most of my career: talk about consciousness as a narration interpretation, and to talk about animal behavior as a way to understand human emotional behavior. But what
Hmm.
happened along the way, people got confused about what I actually was talking about, because many people would introduce me at lectures as someone who had discovered that the amygdala is the seat of fear in the brain. Now, when
Hmm.
you say fear, most people think conscious fear, the feeling of
Hmm.
fear. But if you're a scientist, fear was behavior,
Hmm.
because behaviorism had dominated the field, and it still does in many ways in terms of animal behavior. Animal
Hmm.
behaviorist researchers do not like to talk about messy things like consciousness, and for good reason. It's hard to know what's going on in rats. Hard enough to study consciousness in humans. Um, but it was, and in fact, when I wrote my first grant, it was rejected because neuroscientists don't study emotion. That is not
Hmm.
something a proper neuroscientist can do. And I was doing studies of Pavlovian conditioning to study emotional behavior. And the guy said, and besides, you didn't have a control group for your Pavlovian conditioning. So
Hmm.
for many years after that, I disguised myself as a Pavlovian conditioning researcher so I could get funding to study emotional behavior. That's how science works sometimes. You have to do an end around to make it work.
Yeah, it's certainly an interesting field, and unfortunately, I have noticed that a lot of, the cognitive behavioral people, they get a lot of funding and they get a lot of press, and people cling to that. I've noticed, especially in the States, I'm in Canada. I've
Uh,
noticed like a lot of insurance companies are like, just CBT it.
I can
That's,
tell you a story about that.
oh, please do.
So, I mean, this is not a story. It's more of, well, it's kind of a story, but it's more of a theory about what happened. I wrote a paper with a fellow from Canada, then actually, um, and we and some others, and it was called "What Happened to the Mental in Mental Disorders." Because so if why is why is something like CBT getting
Hmm.
insurance coverage when talk therapy isn't?
Yeah.
So if you look at the history, let's just look at the history around 1950. Um,
Hmm.
that was a time when medications were beginning to be developed in the psychopharmaceutical industry. And that was also a time when behaviorists still dominated psychology.
Hmm.
So the pharmaceutical industry um, accidentally discovered some treatments that helped things. So, for example, there was a tuberculosis drug that was being tested on patients on a ward, And they gave the drug to the people. Their TB didn't get any better, but they noticed that the mood had changed a little bit on the
Okay.
ward. So that then became the first kind of antidepressant drug. Um, then there were other drugs that were discovered all accidentally. All the major classes of drugs were discovered accidentally in the 1950s and 60s. And then the pharmaceutical industry said, well, we got to get more scientific about this and approach it in
Yeah.
a kind of more high throughput kind of research. Let's study some rats and mice and see find some new medications. So all of the studies since the 1960s, over and over again, the only thing that they could do was rediscover the same kinds of medicines that had been accidentally discovered because they didn't know what else to look for. So you get benzodiazepines, get more and more and more benzodiazepine types, and reuptake inhibitors, serotonin, norepinephrine reuptake inhibitors. Nothing is new since the 1960s.
I
Um,
remember reading an article and it was in an academic journal. I forget which one. And it was basically saying that they didn't even know why SSRIs helped.
no, it was
Like
accident.
to this day, that they're just like, they just seem to. And this came out like recently. And I'm reading it and I'm like, okay.
So anyway, at that time, psychiatry was also um, thinking, okay, we have to get more. We've got these medicines coming, so we need to become more scientific, more rigorous, less Freudian, right? Because psychoanalysis was dominating psychiatry right before World War II. A lot of European psychiatrists, psychoanalysts came to the U.S. and probably Canada and Argentina and lots of different places. Um, and they became the dominant force in psychiatry in the 40s. Um, but then by the 50s, the drugs were coming along, and the idea was, okay, we need to make psychiatry more scientific, more quantitative, less Freudian, less about talk and more about data. And that idea of more about data is why everything today is about metrics. You have to have a metric that something you can measure, and the amount you can measure, and then you can get a reimbursement for it. So the whole system is based on a lot of false premises about how things work. There's no way that you can put a rat or a mouse through a task, give it a drug, change its behavior, and then give that drug to a person and expect it to change its mental state. Because behavior is one thing, but mental states are quite different. And that's the big problem when we use the word fear to describe behavior, which is common in my field of neuroscience. We studied freezing behavior as a measure of fear. And I did that for years. And I talked about it that way too, because I was just in the field and that's how you talked about it. But it's wrong. The brain mechanisms that control freezing behavior or avoidance behavior or physiological arousal are not the brain mechanisms that underlie your mental states and the anguish that comes with fear and anxiety, that define fear and anxiety, the mental anguish of fear and anxiety. Those are separate from the behavioral and physiological responses. And until we recognize that distinction, the mental will never be back into mental disorders.
I do have a question, and if you don't want to answer or feel comfortable, that's fine. I'm just curious, how do you feel about exposure therapy for like phobias and anxiety and PTSD?
Yeah. So the problem, I told you what the problem was, but I didn't, let's say you have a person who has social anxiety disorder.
Hmm.
And there are two scenarios that the psychiatrist may tell the person. One is that the we have anti-anxiety medications. You'll
Hmm.
take a medication and you'll feel less anxious. The other scenario is we have medications that treat certain symptoms, like your avoidance of parties uh, and your physiological arousal while you're at the party. The medication will dampen the behavioral and physiological responses a little bit and make you a little more comfortable at being at the party. It's not an anti-anxiety medication. It's going to help you with your behavioral and physiological symptoms. And maybe, you'll be able to, with that help, you'll be able to relax a little bit. If you start to feel a little anxious, you step out and, go do whatever. If you smoke, go smoke or go make a phone call or something. And then you come back in and you can kind of slowly do a little bit of exposure therapy on yourself as it feels comfortable.
Mm-hmm.
Um, if that's how the medications had been advertised, the second scenario, no one would be complaining about the medications. They would be doing what they were designed to do in the animal studies. But
Mm-hmm.
because they're expected to be the cure for anxiety and fear, and they don't work, everyone's disappointed. The pharmaceutical company, the psychiatrist, the patients. But the drugs are doing exactly what they were designed to do in the pharmaceutical company. The pharmaceutical, they won't come to, they cannot understand that it's not about simply behavior. Um,
Mm-hmm.
and so, because they aren't getting results that they promised, they're pulling resources out for studying how to make better treatments. I think that's probably okay because they're never going to find it that way. You're going to
Mm-hmm.
find fear and anxiety as subjective states by listening to what the patient has to say.
Mm-hmm.
Now, but I do think that if you, let's just take a generic situation where you want to, let's say you want to do CBT on a patient who has spider phobia. Um, First thing you have to do is make the patient agree to take that,
Okay,
you
but
know,
who's going to do the CBT on me first?
sorry.
I said, who's going to do the CBT on me first so that I could do that with spiders?
So, but what the idea is that if you could like extinguish the stimulus, the spider stimulus,
Mm-hmm.
amygdala, reducing the amygdala's behavioral and physiological responses to the spider without the person actually knowing the spider is there. In other words, doing subliminal extinction. Present the
Mm-hmm.
stimuli very briefly so they get to the amygdala. They turn off the amygdala if you repeat it enough, and then the person is more comfortable. And you say, "Well, you were just seeing a spider," and the person, I didn't know I was seeing a spider.
Mm-hmm.
So now you can talk about it and talk about memory. So the first step would be tame the amygdala. Second, and to reduce the behavior and physiology. Second step, tame the hippocampus to kind of change your memory about who you are and your relationship to spiders and all that sort of stuff. And
Mm-hmm.
then you have a brain that's prepared to do talk therapy without all the other baggage getting in the way. So that's my advice for the field there.
I think it's pretty good advice. And I mean, I'm new to counseling, but the advocacy thing for a while. And I do have a few qualms with how some people have tried to treat certain disorders. And
Uh-huh.
you kind of just have to realize that, patients, clients, etc., are allowed to accept the practitioners they accept and kind of raise your hands a bit. So, moving on from all of that, I
Yeah.
guess I just want to go back to the book and say, what inspired you to write this particular book? I know you've come
Yeah.
on. It doesn't want to show it at all,
The four realms of existence.
which apparently doesn't exist. I'll
Hold it in front
definitely.
of you, probably. Then, no, okay.
Oh,
there,
there
there
we
you
go.
go. Four realms of existence, a new theory of being human.
And I will definitely put links to buy that and to find your documentary.
Oh, great. So, why did I write that book? Okay, the couple of years before, I'd written a book called The Deep History of Ourselves. 2019, it came out. And the basic story in The Deep History of Ourselves, the subtitle is The 4 Billion Year Story of How We Got Conscious Brain. So I trace the history of danger all the way back to the beginning of life. And the point was
Mhm.
that the first cells that ever lived had to be able to detect and respond to danger. Otherwise, they couldn't live long enough to divide in half and generate another cell. So, so I traced it all the way down to that. And then I traced it all the way back up to describe how different organisms respond to danger. And finally got back to the human brain. So it was a book about kind of the way we were evolutionarily, how we got to be who we are through the long process of evolution. Excuse me. Um, but I thought what I wanted to do in the next book, excuse me, so what I thought I wanted to do in the next book was to write about the way we are rather than the way we were. Just take human beings and take everything we know about. There's a lot of we know a lot about psychology and neuroscience and so forth, but we don't have a kind of overarching understanding of how it all goes together. So I had an idea about how it could all be pieced together into a set of principles or fundamental set of organizational principles. One was that all the organisms that have ever lived have existed biologically. So humans all the way back to bacteria have existed biologically. Now, some biological organisms also have a nervous system and exist neurobiologically. So that means basically we're talking about only animals because only animals have a nervous system. All the other life forms, all the plants, all the fungi, all the single cell organisms, bacteria, protozoa, and all of those exist without nervous systems. So they don't exist neurobiologically. And some neurobiological organisms, some animals, also have sophisticated cognition. So those are cognitive organisms. And then some cognitive organisms are also conscious. Now, with biological, it's very easy to say, is this a biological organism? If it's alive, it's biological. If it's not alive, it's not. Neurobiological, it's very easy. If you have a nervous system, you're a neurobiological organism. If you don't, you're not. So we start with all organisms, then we get to organisms with nervous systems, and then to organisms that have cognition. That's much harder to define because we don't have a physical thing that we can pin it on. So it all depends on one's interpretation of what they mean by cognition. So for me, the definition of cognition is the ability to use a mental model in your head, a model of the world where you can make choices and hold information in mind, make decisions, choices, and take care of your life in a kind of more programmatic way than simply being a stimulus response machine. So the neurological realm is characterized by stimulus response behaviors, reflexes, fixed action patterns or instincts, depending on what you want to call them, stimulus response habits. Those require no cognition. So we know that all animals from the earliest animal, which would be sponges, through we throw sponges out because they seem to have lost a nervous system way back in evolution. So let's start with jellyfish, all the way up to invertebrates with nervous systems on one side of the equation from jellyfish, on the other side, vertebrates. And both invertebrates and vertebrates have a central nervous system in which they can control their behavior in terms of a reflexive way, in terms of a conditioned associative way, and also in terms of a stimulus response way. So fixed action patterns too. Both vertebrates and invertebrates do that. And we know that some vertebrates have cognition. Up to through reptiles, we have just kind of the neurobiological behaviors, but in mammals, we get cognition. And some of those mammals also are conscious. Now, we don't know which other animals are conscious. We do know which animals have cognition because we have behavioral tests that are pretty good for marking that. But we don't know which animals have consciousness, except humans. That doesn't mean other mammals say don't have consciousness. It just means it's hard to know what's inside their head. We all project our emotions onto them. Charles Darwin was having trouble getting his theory of evolution accepted in Victorian England in the 1800s, and because the Victorians were very religious, believed in the creation story of life, and that all animals, all creatures were created at the same time. But he was trying to say, no, it goes back billions of years to the beginning of life, and it just wasn't going over well in England. And so, and his wife, her name was Emma Wedgeworth. They in that time everybody exchanged letters, so there are these letters from Emma to Charles when he was off on on his voyages on the Beagle and so forth, exploring the world. And one of her letters was about how she feared that in the afterlife he would be in hell and she would be in heaven because of his anti-biblical story behavior, all these speculations. So he came up with a way he thought would allow the English people to be more accepting. Instead of talking about humans as having animal emotions, he talked about animals as having human emotions. So everything else in evolution is about, we've inherited it, and it's not like they're saying that animals inherited emotions from us, but that they have our kinds of emotions. And we all have. If you have a pet, it's conscious and it loves you. It's doing great things.
They can manipulate you.
They can manipulate you, but the question is, how are they doing that? Are they doing that because they have all this sophisticated cognition? They probably have pretty good cognition, dogs, cats, and so forth. And birds have amazing cognition. But the question is, do we know that they're having a conscious experience? That's a very complicated thing, and that in our brain, we're still trying to figure out how that works. So, my idea is to say that, I believe that consciousness is an extension of cognition. And what we can do in animals is we can take their cognitive processes all the way to the finishing line, but we don't know if they cross the finishing line into consciousness. But they have all the stuff that will allow consciousness to happen. But whether it happens in them, we just don't know. So it's a little complicated, but I think I have this idea that we could, if we knew more about human consciousness and the brain areas and circuits involved, and we found those brain areas and circuits in rats, then we could say, okay, rats probably have what we have in terms of that kind of consciousness. And there is a kind of consciousness that is in a part of the human brain that is shared by all mammals, and that's in the medial prefrontal cortex. And that kind of consciousness is called anoetic consciousness. It's a kind of implicit, no content. It's just the feeling of rightness, that everything's okay. So you walk into your apartment, you don't have to say, this is my apartment. Everything feels all right, so it's all right. But if all of a sudden there are books knocked over or something is wrong, it's not okay. And that bumps it up into another level of consciousness called noetic, where you know what has happened. And then finally, a kind called autonoetic, where it has happened to you. So those three kinds of consciousness, if we understood those better, we could then kind of retrofit consciousness into other animals. So I think it's pretty clear that we could do that in terms of anoetic consciousness and medial prefrontal cortex. And I think it's pretty clear we can do that for all primates in terms of dorsolateral prefrontal cortex and noetic consciousness. Now, autonoetic consciousness, some people argue, is only something that humans can do. It's a conscious state in which you are the entity having the experience. But we don't know we can never know what's going on in another animal. So it's kind of a bit of, human chauvinism to say that we're the only ones who have it. But, certainly great apes probably have something like it. But there is a part of the human brain that is only present in the human brain. And if that's where our autonoetic consciousness comes from, it would be the case that only humans can have that kind of consciousness. So by using neuroanatomy, we can make speculations. The problem in a lot of the animal consciousness field is that they have no doubt. They know that their dog, their cat, is feeling those things. There's no question. And the only thing you have to do to prove animal consciousness is to make it look like human behavior. If animal behavior looks like human behavior, it must be conscious. But as I told you, for fear, the behaviors that go with fear are not controlled by the fear that we experience. So we have to be careful when we don't want to overstep the projection of things to animals. Um, Marion Dawkins, a very prominent animal welfare person in the United Kingdom, has said that if we tie the problem of animal consciousness to if we tie the problem of animal welfare to the problem of animal consciousness, we do more harm than good, because it's much harder to make a case for animal consciousness than it is for animal welfare. So we can go much further in taking care of the animal's conditions without bringing up the difficult problem of animal consciousness. So I truly believe my cats are, loving and conscious and smart as hell. And we have one cat, Smokey, the really long cat. He's learned to reach up and pull a handle down to get into a room.
Mm-hmm.
The other day we had a flood in our apartment, which we didn't notice was happening. He was in the living room, jumping around, jumping on our lap, jumping on our lap, to take us there to show it to us. So he's a pretty smart cat. So yeah, I give him a lot of human. I'm doing a Darwin on him. I'm giving him all kinds of human-like consciousness.
Yeah, I definitely remember back in university reading Life of Pi and going on about anthropomorphism and how, humans, we do this all the time. Even with silly movies like Cars, like we seem to, even inanimate objects, we put our own
Absolutely.
emotions on
Yeah,
everything.
yeah, that's true. I mean, it's there's an anthropological theory that says that anthropomorphism is an innate tendency of the human mind, because early humans, in the effort to domesticate animals, had to put their mind, the human mind, into the animal mind to figure out how to manipulate it. And it was basically, it was kind of like the invention of behavioral psychology in a way, because they were using their thoughts about human behavior to get animals to behave in a way that was useful to agriculture. And so this may have been built into the human mind, but just because we believe that doesn't mean it's true. So that belief could, I don't know if we can have an innate belief, but if let's say you have an innate belief, that doesn't mean it's a fact. It's just a belief.
Yeah, that's quite interesting. And I was wondering if you could expand a little more on what preconscious is, especially when it relates to neurophysiological disorders and where
Sure.
obviously there's a behavior showing after.
Right. So so let's take the four realms of existence: biological, neurobiological, cognitive, conscious. Biological, we're not. I don't want to talk about bacteria can move around and do things, but let's talk about animals. The three kinds of behavioral control in animals are: it's neurobiological, taking care of reflexes, fixed action patterns, instincts, and conditioned responses, and non-goal directed habit, stimulus response habits. Not goal directed is sorry about that. I'll do it again. So there are three levels of behavioral control in animals that are important to talk about: the neurobiological, which includes reflexes, fixed action patterns, also called instincts, um, conditioned responses through Pavlovian conditioning, and instrumental stimulus response habits learned through trial and error. None of those require cognition. They're simply behavior. So that is a level of behavior that is not doing anything for us cognitively. Cognitive behavior is goal-directed behavior, where you have a goal in your mind that you can pursue by making internal decisions about what are the options. Now, it's been said, there's a very strong theory that the reason that birds and mammals have this sophisticated cognition is because they're warm-blooded. Those two things go together. Now, why the heck would you? Why does that happen? What's the answer there? Well, it's actually very interesting. The idea is that um, the in order for the brain and body to maintain warm-bloodedness, it requires a lot of energy. It generates it burns a lot of fuel to keep the body at 98.6, right? Or whatever the temperature of your animal friend is. So, um, and how do you do that? Well, you have to burn more fuel to get the fuel to eat. So it's a very, very, very energy demanding, energy using operation. And birds and mammals do this. So what's the answer to why? Well, because it's so energy greedy, you can't afford to make a mistake about where to go looking for food. You got to be able to get regularly and reliably obtained food. I mean, we humans need food every, I don't know, few hours, right? Some animals can go a day or two, and but then you get hungry, or if you need water, blah blah blah. So you need to be able within a short period of time to be able to get what you need. It's not necessarily where you live because you got to go out and forage. You live where it's safe to live, and there aren't predators that can get you. And to go out foraging, you're going to be exposed to predators. So you got to know where the predators are likely to be and where they're not likely to be, where the food is likely to be this time of year, as opposed to some other time of year. What what are the consequences of it being raining or it's possibly going to be raining? All of that requires a lot of planning and strategizing and cognition. So cognition and warm-bloodedness kind of evolved in parallel. It's not like, one happened in the other. It's like they came together because both needed the other to work.
I find this interesting because I have like thoughts going through my head, and like a couple things I always say to people with misophonia. Like the first one is, if you're tired, hungry, or whatever, if one of your physiological needs aren't met, of course you're going to be in fight flight. You are at risk. And then the other one was
Yeah, so
when
let
we
me
go
just
out in
comment.
public and strangers are around, I'm like, do you realize that of course your fight flight is worse in public? Because you're just that person, like you described, out there foraging for what you need.
Right,
And sure, in the modern society, we have rules and laws, and something probably won't happen, but our little brains don't know that.
right. So the first point I'm just comment on point one, which is the physiological capacities that are controlling metabolism for allowing you to anytime you behave in any way, you need metabolism. And a lot of that metabolic work is being done in sort of the same kinds of systems of the brain that do these neurobiological responses. So, for example, the uh, you have a habit of when you're going to eat, let's say, and so you need to. Okay, I'm not. Let's scratch that. It's too complicated. I'm not going to go into it. So just take that part out.
So I do want to say, like, do you have any advice for people who, might have these kinds of disorders and they're struggling with the same concept as the book of self, and they're wondering, are these disorders part of themselves? Are they a failure somewhere? Like, it seems like people get really emotional about the fact they have these conditions, whether it's
Right.
anxiety or depression, misophonia.
Yeah. So it's you're everything about a person is there's a little bit of a genetic component and a little bit of a experiential component. And the genetics you have no control over.
Mhm.
The experiences, you know, you can't, I don't think we can necessarily blame people for their experiences. I mean, some people, do things that are risky or get in trouble in various ways, but through intentional choices. Um, but not everything that a person does is intentional. And a lot of stuff happens to you I mean, you don't, if you're in a situation where there's a you're on a bus or something and there's a huge traffic accident and the bus is on fire and all kinds of bad things are happening. That's not your fault as being a bus rider, you know. That's just a matter of circumstance. And yet you're likely to suffer from that for quite some time afterwards if it was very traumatic. So it's it's I guess we have to ask in each case how much of the individual's contribution to the situation they find themselves in is their fault. But even if it's their fault, that doesn't mean we shouldn't help them. We just have
Mhm.
to help them understand that they made a bad decision and try to walk back on, re-narrate the story, because narration is so important in all of this. You don't want to call somebody a depressed person, or you want to say that you have depression. You might be
Mhm.
a person who's suffering from some kind of depressive problems, but it's not your fault necessarily. It's just how things in life play out because of all of the stuff that's happened to you even before you could talk and walk, and it all starts happening. That we hear a lot about deep learning these days and AI and all that stuff. But
Mhm.
in many ways, the human body and brain are a deep learning system. Every moment of your life, your cells in your brain are learning about the situation that you're in. And ultimately, that is what gives us that kind of anoetic feeling of rightness or wrongness, that you have lived your whole life with your brain and your body. And so when everything is working properly, you don't have to worry about it. But if, say, you're
Mhm.
a person in whom sounds are troubling to you, those you're going to be attentive to sounds, even if it's not a sound that's going to trouble you, because you have acquired a sensitivity to certain kind of situations. And I guess that's true of any kind of problem that people have psychologically. We get hooked on the cues, and then it's hard to dissociate the, the rest of your life, that the things that you want to do, because the cues become so dominant.
Mhm. I
And I think
gotta
that's
say, I can think of like a zillion questions to ask you. Like, I did want
well,
to,
I'll be happy to come back. We can do it again sometime.
I think we should because this is all so fascinating. And I think, important too to actually just talk about it and not, because, you can read a research paper and, you can get the gist, but it's a lot
Yeah.
different than, because all of these scientific endeavors, they're truly human at their, we study things, we study the brain science because of a love of humankind, I think. And I think sometimes scientists kind of are lost in their labs and they're not actually getting to communicate the values. And I think it's great when we can.
Yeah. One of my pet peeves is that we scientists have become very, when I got into all this, right, when I wrote my first book, The
Hmm.
Emotional Brain, I was very nervous about doing it because at that time it wasn't cool for a scientist to, you know, pander to the public, so to speak,
Yeah.
communicate with the public. Um, and there weren't many people doing it.
Hmm.
But over time, it's gotten very, very popular. And so a lot of scientists do it. And they think it's a way to like be, kind of loosey goosey with everything. But that's never been my principle. I always try
Hmm.
to write a book that a scientist who reads it will learn something from it and not view it as just, pop science. Because I
Hmm.
don't write pop science, I write real science that
Hmm.
is, well, it's not always easy for a layperson, but I think many lay people have found it a way to manage to do it.
Hmm.
I try not to put too much in, but you gotta have the details there in order to make it legit.
Yeah.
And I want my readers to feel legit. They're getting the real thing when they read me.
Yes, absolutely. And that does show on the page, I can say. Especially, I mean, even my my degree, my bachelor's was in political science. So as I'm reading this, you're throwing in these philosophers. And I'm like, oh yes, I've read these. And it was nice because it was a very holistic approach because I find a lot of science like they go for their field and their field alone. And I liked
Mhm.
that the book was more, I don't know if I want to say holistic, but more,
Layered. Let's try that.
yeah, like it had different forms of thought. And I'm really big on that. Like I take my knowledge from every single sphere. I find it very interesting. I did have a couple more questions, and I don't
Yeah,
know
okay.
really how much you can answer on it. But this, since it will be at the Misophonia conference, I was wondering if, you could say anything about the lab study on rats that happened a few years ago. I know it
Sure.
never got published.
Right. Yeah.
So, a few years back, your lab conducted a study on fight, flight, freeze, and audio triggers in rats. Were there any interesting findings on, what we might call misophonia?
Yeah, so we received some funding from Jennifer Brout and her foundation to study auditory sound. My lab was studying auditory stimuli being paired with a mild electric shock. You could think of that as being related to some kind of human condition where some sound is associated with some situation that's aversive. Um, and the this is what took us to the amygdala, following the path of the auditory stimulus through the brain, and the amygdala was kind of in the middle of the whole thing. Now, in the study we were doing with funding from the Brout Foundation, um, we were looking at differences, individual differences in animals. Some of the animals we found would freeze quite a lot to the stimulus. Those were, we called them high freezers. They were especially sensitive to the sound. And others were low freezers. In other words, the sound didn't make them freeze that much, despite being associated with an aversive situation. So the idea was that if we could learn more about those individuals that were especially responsive to the sound, same aversive response, aversive conditioning situation, but one animal will show a large response to freezing, and another animal a small response. So these two groups came to be the core of the project. Uh, the goal was to go forward, trying to break it down further to understand maybe some of the more the aerial components within the amygdala, where the high and the low freezing cells were located, and maybe the molecular mechanisms that were underlying that kind of stuff. Um, but we had issues with the completion of the project, and then this pandemic hit, and the whole thing kind of fell apart because we couldn't do research for over a year, and so we never were able to get back to it. Because after the pandemic, I started moving towards the closing of my lab and retirement and so forth. So
Well
unfortunately,
deserved retirement, though,
we
after numerous years of scientific rigor.
yeah. So yeah, that's
And
what
I do
happened.
have
And
one last question, if you're
okay.
all right with that. I guess my one last question is, and this is speculative, not like I'm expecting a definitive answer. Do you think that maybe someday there could be potential treatments for this, such as memory reconsolidation?
Yeah, so memory reconsolidation is something that my lab spent a lot of time on, and starting in 2000, where a young postdoc in my lab kind of stumbled across this stuff. And reconsolidation is the idea that when you retrieve a memory, it becomes vulnerable to change. And at that time, um, you can add new information to the memory, or the memory can be altered in some way so that it's no longer as strong as it was before. So the idea was to be able to find ways to make the memories less strong, and the this required medications and that we could use in animals, but that were never really appropriate for use in humans. The only one that these would be potentially toxic in humans, and we just couldn't. There would be no way to have that approved for
Understandable.
research. Yeah. So the one medicine that worked somewhat was propranolol. which has often been used for things like stage fright and so forth. It also kind of lowers blood pressure a little bit. And so some researchers in Canada at were they at McGill, or I think they might have been at the uh, what's what's
Not
the Montreal
actually.
University,
I can't remember.
University
I
of
think McGill,
Montreal.
yeah, I think
Yeah.
McGill is in Montreal though, isn't it?
No,
Also?
McGill's in Montreal, but so the
Mhm.
guy was either at McGill or at the University of Montreal in
One
Canada.
of them.
um, and they were doing studies on patients that had PTSD and
Mhm.
trying to use reconsolidation to alter their trigger cues and stuff. And they got a small effect with some,
Mhm.
but it's been hard to replicate sometimes, and
Mhm.
it's just not a robust enough effect to really go forward. But the research that we did between 2000 and 2010 or 12 on this, um, people were craving to get the memory pill. And it was, really it was, some people would call and say, I need the pill to get rid of the memory of my ex-wife. But others had more serious problems and really,
Yeah.
and unfortunately, there was nothing that we could do because it was just not a viable
Mhm.
thing in terms of the medications. We did develop a kind of behavioral treatment that sort of worked as well, but it was even harder to replicate. About half the labs that tried it replicated, and about half couldn't replicate it, doing exactly the same procedure.
I
Um,
definitely find that interesting. Not for now, but like if you ever want to send me a link or information, that sounds fascinating.
Well, it wasn't because the science was bad, because it's just that the procedure is not the ideal one for
Mhm.
capturing the phenomena that we wanted to capture. We couldn't figure out exactly how to go beyond that. So, we really tried, and it's uh, it's too bad that these things aren't more effective. But I guess we'll see what time. And people are still working on it, so a lot of active
One
labs.
thing I try to really hammer in with people, especially that come to Misophonia International, they want to know when will there be a treatment, blah, blah, blah. It's you really got to explain to people, as far as we've gone with science, as like magical as it seems, there's still so much we do not know.
Yeah.
Like a lot of it is even stabbing in the dark for a lot of
Mhm.
disorders. And then, like you said, they accidentally found antidepressants when they were doing something else. Like,
Right. The other thing is, almost all of the studies until recently have been done on male animals. So
mhm,
there's the very poor female analysis of this. I'm not saying that it would be any different in females, but it
mhm.
has to be looked at to see whether there's any difference, whether they're more responsive, less responsive, because you never know what's going to work, right?
Yeah.
Maybe it'd work in females and didn't work in males.
And it is interesting because, just anecdotally, I don't know if there's a bias of women are more likely to speak out, but we definitely see far more women reach out to us than men.
Hmm. Hmm.
But
Hmm.
that could be social stigma, that could be
Right.
so many
Yeah.
other things. And I mean, the first study I want to do right now that I'm getting out there is like a treatment perception, because all these like CBT people, they're treating misophonia and then there's no follow up. They're like,
Hmm.
oh, they felt way better. I'm like, yeah, but maybe that was a placebo that someone told
Hmm.
them that they were not crazy for the first time.
Right.
And so that's what I'm really big on, that like the lack of follow ups is just,
Hmm. Hmm.
there's definitely room to improve, I think, in some of these areas.
Yeah. Well, I wish you luck. I appreciate the hard work you're doing for these people, and maybe science will come through at some point. So
Hopefully.
keep pushing us. Keep pushing
In the
us.
meantime, I'll keep my little brain,
Okay.
my little stress ball.
And mine's still in my head, so I can't pull it off. Oh no, I
Well,
can.
thank you.
What?
Oh,
Yeah, I got one here too.
perfect. And I want to thank you so much for
Thank you,
coming on
Shaylynn. It's
and
been
doing this
great.
video.
Enjoyed it. Thank you.
And thank you so much. I will, for those who are watching, I will put the links for Joe's book where you can buy it and where you can watch the documentary, which is not just about science, it's also about music and his life. And I believe Roseanne Cash is there with you as well in that
That's correct.
documentary.
Yeah. Yeah. She sang
So
on one of my songs.
anybody with any interest can enjoy that documentary. So thank you so much
Thank
for
you.
this today, and I hope you have a nice rest of your day.
Thanks. Bye.